Okay. As people are joining here, I want to welcome everybody. I'm Joel Angelillo, one of the members of the Metro West Climate Solutions Steering Committee. We are happy you could all join us tonight. And I think people are still coming in. So let me introduce, while people are coming in, Metro West Climate Solutions is a partnership of local groups who want to speed our path to a healthier carbon neutral world. A partnership that includes First Parish of Wayland, First Parish in Weston and in Lincoln, the Sustainable Weston Action Group, Energize Wayland, and a growing list of organizations. And since 2019, we've been holding roughly monthly meetings and webinars on climate-related issues. Topics have ranged from Beacon Hill legislation to offshore wind, and to tonight's topic, which is heat pumps. If you would like to receive news of upcoming Metro West Climate Solution events, as well as events hosted by other Metro West groups, go to metrowestclimatesolutions.org. You can see the URL on the screen to sign up for our newsletter. And you'll also find recordings of previous sessions. Speaking of which, this session tonight will be recorded and available soon on our website. The topic tonight will be introduced by Steve Breit from HeatSmart Alliance. Following his overview of heat pumps, 3 residents of Wayland and Weston will talk about their experiences installing heat pumps. As you can see here, we encourage your questions. Questions is what this session is all about.
Can I just be monitoring questions on the chat?
Yes, and Jeff will be monitoring them as they come in. And use the chat button on the bottom of your screen, but feel free, any and all questions. That's why we're here, to help you become more informed. I want to say a little personal history. When I was 6 years old, I think the first spanking I ever got was from playing in our coal bin, located in the basement of our Victorian house in Louisville, Kentucky. Black, sooty, dirty rock that kept us warm in the winter. Well, for the past 60 years, I've been living in houses or apartments that have had fossil fuels, trucked or piped thousands of miles to my basement, where I burn them on site. Some of the heat going into my house, hopefully most of it, and some going up the chimney. That is, until 6 weeks ago, when I first had a heat pump installed. Clearly, a significant portion of the electricity that runs my new heat pump comes from burning fossil fuels hundreds of miles away. But hopefully that will change soon. If I'm like most others, about 10% of the CO2 I'm responsible for comes from keeping my house warm. Home heating is an important issue and must be dealt with if Massachusetts wants to reach its goal of carbon neutrality in 2050. Well, I'm pleased to welcome Steve Breit to lead our webinar tonight. Steve is co-founder of HeatSmart Alliance. HeatSmart is a group of neighbors helping their fellow neighbors make informed decisions about how to heat their home. You can use, they can use your help, in fact, to become a HeatSmart coach in your community. Sounds like a very rewarding job to help your neighbors become more informed and make these decisions. At this time, I'm going to turn the mic over to Steve, and I will stop sharing my screen. Steve.
Okay, thank you, Joel. So I will share my screen. All right, so the topic for tonight's webinar is clean heating and cooling for your home. We talk about heat pumps. Heat pumps are a technology, but this is really about changing the way we heat our homes. And so that's what I'll cover in the next 20 or so minutes. And then we have testimonials from 3 neighbors in Weston and Wayland who have already installed heat pumps. So Joel, you did a great introduction to the HeatSmart Alliance. I will just mention again that we're an all-volunteer organization, and our mission is to reduce greenhouse gas emissions by adoption of energy-efficient heat pumps in Massachusetts homes and buildings. We currently have 75 members and associates from 32 Massachusetts communities, and every month we grow. We don't accept donations from or referral fees from installers or manufacturers so that we try to maintain our objectivity about heat pumps. Why heat pumps? Well, in Massachusetts, about 30% of overall energy use is due to residences, to what's used in homes, on site in homes. And of that, about 60% is for heating and cooling, another 17% or so for hot water. Also, clothes drying is roughly 2% if you do it with, well, regardless, and the rest is 20%. So you can see of the energy used in the home that a large part of this can be addressed, about 80%, by various kinds of heat pumps for space heating, for heating hot water, and even for clothes drying now. So paths to decarbonizing your home are to weatherize, to improve the insulation and air sealing. If you're in a community that's served by Eversource or National Grid, which is the case for Weston and Wayland and many of the surrounding communities, you have access to the Mass Save program, and they do a lot of this work at no charge or very modest charge to the homeowners. So weatherizing the home to improve, to reduce the heat loss, electrifying everything in sight, electrifying the heating, electrifying the car, electrifying how you cook and so forth. That's a part of it. And then shifting to renewable electricity, which could be solar on the roof. But if you're living in a home like I do that's got a lot of shade and many trees, solar on the roof isn't practical, but there are other ways you can get green electricity through community solar projects, or the Green Energy Consumer Alliances offers a way to get 100% green energy. And now many towns offer community choice aggregation electricity, CCA, with 100% green option. What's a heat pump? Well, it moves heat from a cooler place to a warmer place. And you already have heat pumps in your home. They're just not called heat pumps. They're refrigerators, dehumidifiers, air conditioners are all heat pumps. You just don't think of them that way. They're available now for home heating and cooling, for water heating, for clothes drying, and even for pool heating. The basic principle for heat pumps, that the most common type of heat pumps for heating homes, air source heat pumps, is that they draw energy for 1 unit of electricity into the heat pump. They manage to pull 2 units of heat energy from the outdoor air, yes, even when it's very cold outside, and pump it into the home. So you get from this sum 3 units of energy, roughly speaking, into the home. And that's why their efficiency is actually greater than 100%, numbers like 3, 4, and for ground source heat pumps, even 5 times the electrical energy in and heat energy into the home. A really important point, even though we call them heat pumps, all heat pumps that are used for home heating provide both heating and air conditioning, heating and cooling. The benefits for heating using heat pumps in Massachusetts homes: substantial reduction in greenhouse gas emissions, and I'll quantify that on the next slide. Energy savings, they're modest savings right now versus fuel oil or propane. Significant savings if you're one of the few remaining homes using electric baseboards. And then a safer home. If you convert to 100% electricity, there's no risk of carbon monoxide poisoning or explosions in the case of natural gas. And they provide superior year-round comfort, heating and cooling. Modern heat pumps regulate the indoor temperature very closely, much reduced swings from conventional heating systems, so they keep homes very comfortable. How much emissions reduction can you expect? Well, this comparison is for a typical 2,000 square foot home. As a point of reference, you can use various carbon calculators that are online for your situation, but a typical the carbon footprint, including transportation and air travel and so forth, for a typical family living in a 2,000 square foot home might be 15 to 20 metric tons per year. So the heat pump, if you're on fuel oil, could be accounting for as much as 30% of the home's carbon footprint. And so when you convert from fuel oil or propane or electric baseboard or natural gas to an air source heat pump, which are the most common type for retrofit situations, you've reduced your carbon emissions by a considerable amount, as much as 5x versus oil, and ground source heat pumps are even more efficient and therefore lower. But the important thing to recognize is if you're getting 100%, your electricity is 100% from renewable sources, then the heat pumps, the emissions you associate with a heat pump are zero. So it's really probably the single biggest thing you can do to reduce your home's carbon footprint and possibly even your household's carbon footprint, including everything you do. So this is important. And so the thing is that then the question is, which type of heat pump is right for your home? And what I've found in coaching dozens of homeowners in Metro West is that every home is unique. We have an older housing base for the most part. And so if you're replacing an existing heating system, a lot of what's right depends on what was done in the past. So, and what I mean by that is, what is your existing heat distribution type? Now, I want to ask Stephanie while I'm, I don't know if we can do the poll, Stephanie, while I'm speaking, or if it has to interrupt. Sorry, this is the first poll. I'd like people to fill in where you live, because that has some bearing on a fuel cost comparison that I'll do later. So we'll give you a few seconds to complete the poll on your screen, and then I'll keep talking. All right, hopefully you've answered the poll. And so one common type of heating system is referred to as hydronic. You have either inside the home, you have either baseboards with hot water pipes or radiators that could be steam or hot water. And so thank you. Here's the poll results. So we have most of the people, about 2/3 of the people in Weston, Wayland, and Lincoln, and another third in other Massachusetts locations. Thanks, everyone. All right, so now, and you have something called a boiler in your basement. There are various kinds of boilers, but it will look like something like this. Now, the next type of heat pump, a common heating system, is called forced air. You have vents that blow air into the home, two kinds of vents, supply vents and return vents. So the air is circulated in the home, and you have something called a furnace in the basement, usually in the basement in Massachusetts homes. Sometimes for 2-story homes, you may have a second furnace located in the attic. So these are the two common types of heating systems, but due to renovations, I sometimes see a mix of these. And so I'd like to, Stephanie, if you could do the second poll on what type of heating system the attendees have. We'll ask, is it hydronic, forced air, a mixture, or you don't know?
I am having trouble relaunching the next poll. I don't know where it went. Hang on just a second.
I'll give you a second more. And
then... oh, here we go. I don't do this as much. Okay, here we go.
maybe Stephanie, you can tell me when you think you have most of the responses.
Will do.
Or just go ahead and put up the results. I'm going to guess before we see the results that it's roughly 50-50. Okay, mixed, and a few of you don't know. All right, so we do have a lot of these hydronic systems in Massachusetts, fewer forced air. As you go further west of Boston, the homes were built more recently and tend to have forced air more commonly, but in Weston and Wayland, we have a older housing stock. All right, so If you have a hydronic heating system, which was about 40% from our survey, usually the most common type of solution in terms of heat pumps is called a ductless mini split system. These are air source heat pumps. They started out as what are called single zone systems, and you've probably seen them, systems like these used. They were largely made by Japanese or Asian manufacturers and still are, with you'll have an outdoor unit that looks something like this and a wall-mounted indoor unit. That's how it got started. These are very efficient heat pumps. And over the last 5 years or so, the manufacturers introduced what are called multi-zone or multi-split systems. You have a single outdoor unit and multiple indoor units, and that could be a wall unit, a floor-mounted unit, or a ceiling cassette, and in some cases, something called a compact or horizontal ducted system that goes usually above the ceiling and has very short ducts into a couple bedrooms or so forth. So when you get one of these, there's no mechanical connection with your existing hydronic system, so it often makes sense to retain the existing fossil fuel system with the baseboards or radiators or what have you as a backup for extreme conditions. If your home has forced air distribution, then a more likely, more cost-effective solution is something called a central air source heat pump. These look very much, if not identical, to central air conditioners. The difference is that the heat pump has the ability to run in both directions, provide both heating and cooling. And one common setup is what's called partial electrification, where you, if you already have central air conditioning, your system is probably already set up this way indoors. You have a furnace, and on top of the furnace, something called a coil that's connected by refrigerant lines to the outdoor unit. And so this is known as a partial because the existing fossil system can provide backup at lower temperatures. Or you can go to a complete electrification where you remove the existing furnace, and now you have something called an air handler indoors, and the air handler has a fan in it plus the coil. So it's just a replacement for the furnace coil combination, and that's going to provide 100% of your heat. Or another option with, if you have forced air distribution, is to go with a ground source heat pump. That is again a complete electrification. The ground source heat pump indoors, which is the only place you have a unit, connects to piping that goes into a well. Usually in this area, the wells are bored vertically as much as 500 feet. Sometimes multiple wells are needed. And then the ground stays at about 50 degrees or higher all year round, so it's drawing heat from the ground. And these heat pumps are very efficient. One caution with either one of these solutions is that the existing ducting has to be suitable. In some older homes, it may not be insulated, particularly if there isn't air conditioning and not well sealed or properly sized for using a heat pump. That's something the installer should be looking at when they visit your home and making a judgment. And in many cases, the ducting can be remediated to solve any concerns that the installer has. A little bit on ground source versus air source heat pump. Ground source heat pumps are higher installed cost, but they also have much higher incentives. They can be as much as 50 to 70% higher efficiency than air source heat pumps, which means lower energy costs and lower emissions. There's nothing, when you have ground source system installed, there's nothing to see outdoors. There's no outdoor units, so there's better aesthetics. And they come with all of the refrigerant already in the system. They don't have to install the refrigerant in the field. And in general, refrigerant itself is a very potent greenhouse gas. We don't want to see it leaking. Most air source heat pump installations do not have leaks, but a small percentage of them will, unavoidably have a few leaks. The leaks can be fixed, but we don't want to see that refrigerant being leaked into the atmosphere. Air source heat pumps have generally lower first costs, the installation cost. The outdoor units sit outside the house, but there's no need to disturb the landscaping for drilling wells and such. They require a little bit of outdoor space as pictured here. And you have options if for ductless systems, again, for hydronic. If the home has an existing hydronic system, then it becomes quite more expensive to install ground source, because currently they're available only with ducting. I want to mention one other type of heat pump water heaters, also known as hybrid water heaters. They are installed by plumbers as well as HVAC installers. They can provide very quick payback versus conventional electric water heaters. And the savings they cost a bit more, but now there's some very generous incentives from the federal government, a very generous tax credit that will probably offset most of the extra cost of the hybrid water heater versus an electric water heater. So that's something to consider. How much will it cost? That's a common question. So here I have a comparison of heating costs for the 2022-23 season. This is really a moving target. Energy prices have changed a lot in the last year, and some are going up, some will go down. Fuel oil seems to be coming down a bit, for example. So it's a moving target, but this is for the average over the last, this year's heating season. And what you see is the most expensive type of heating, and this would be for a typical 2,000 square foot home. The most expensive type would be electric baseboard, costing over $6,000 per year. Next would be fuel oil right now, and quite a bit less than baseboards, but still more than the air source heat pump, a bit more. So you can sort of consider that air source heat pumps are a little bit, may save a little bit right now over propane and fuel oil. Looking back a year, propane was quite a bit more expensive than fuel oil. So this does change year to year, and it's not something you can, any of us can predict well. Ground source heat pumps cost a bit less, and unfortunately, in terms of our climate and carbon emissions, natural gas is still priced so that it's the least expensive heating fuel. That said, it's not too far off ground source heat pumps, and there are ways you can combine an air source heat pump with a natural gas and what I called a partial heating electrification. Only absorb a very small additional cost each year and yet cut your carbon emissions by 50% at least. So, again, this will vary over the lifetime of the system, and who knows where prices will go over the life of your system. I'll cover here briefly financial incentives for 2022. Sorry, this should be 2023 for Mass Save Residential. There's a whole home rebate of $15,000 for installing a ground source heat pump, $10,000 for a whole home air source heat pump, or if you do a partial home, $1,250 per ton. A typical home will take 3 to 5 tons. So let's say it's a 4-ton home, you might be looking at roughly $5,000 and change in a rebate from Mass Save. Mass Save also offers their heat loans, which are 0% for 7 years. With inflation what it is right now, that's a great deal too. And there are additional benefits for folks who are considered income eligible and qualify for those benefits. There's now the Federal Inflation Reduction Act, or IRA. There are tax credits that started in effect as of January 1st this year, and the IRS has posted the rules for claiming those tax credits. 30% on ground source heat pump, that's back up from 22% last year, I think. and up to $2,000 for air source heat pumps, up to $2,000 for heat pump water heaters. And these amounts are in addition to the mass save amount rebates. So there's pretty generous rebates available right now. There may be from the IRA some income-based rebates. Those are still being sorted out and at the state level. And so I would certainly not hold up. If you need a new heating system, I would not wait for these rebates because who knows what they'll be and when. So one useful resource is a website called rewiringamerica.org that has a calculator that looks at some of these benefits. So when you're thinking about a heat pump, you want to look at the first cost difference. You should consider both the heating and cooling equipment in the home. In most cases, you'll end up replacing both of those systems when you adopt a heat pump. Consider the incentives that are available, which consist of these rebates I just covered and interest-free loans and tax credits. And you might also consider assigning a price to the carbon emissions. What's the value of saving, reducing your carbon footprint? There is some evidence that heat pumps increase home resale value. And you also, if you can value comfort improvements, for example, if you don't have central air conditioning now, adding a heat pump gives you central air conditioning, and that to me is a pretty big value add, and certainly will be valuable add to the resale value of a home. And then again, we don't know where energy prices are going, so there's some uncertainty about these analysis. So what can you do? Your action plan. It makes sense to convert to a heat pump financially if your heating equipment or cooling equipment is over 15 years old. 15 years for air conditioning equipment, maybe a bit more, 20 to 25 years for most heating equipment. With water heaters, electric water heaters, if it's over 7 to 10 years old, you want to be thinking about replacing it. And even other types of water heaters, the tanks tend to corrode at that point. And so you don't want to. And the key thing that all the installers will tell you is plan ahead, don't wait for it to fail. It does take weeks to months to get estimates from multiple installers for a new heating system. And then you have to make a decision, and that can take some time. So this is not something you want to be doing when it's 5 degrees out and your heating system has failed. At that point, your only option may be to replace your existing heating system with another one of the same type, which would be a real shame. If your home doesn't have air conditioning yet and you want to add it, then heat pumps provide air conditioning, and that's a good reason and a good time to consider a heat pump. In fact, there are no incentives now for adding a central air conditioner. There are incentives for adding a heat pump. So in almost all cases, if you wanted to add central air conditioning, it would make the most sense to add a heat pump and use it for heating as well as cooling. And finally, if you're planning an addition, renovation to your or a new home, then it should be planned from the start that you're going to use a heat pump for 100% of the heating cooling needs. There's no reason at this point to think in any other direction. So how do you get started? Well, on the HeatSmart Alliance website, we have a page. If you go to our website, it's called the Learn page, but here's the actual link to resources. And we have links to a lot of the consumer-friendly resources that the state offers, particularly from the Massachusetts Clean Energy Center and the New England Energy Partnership. So we don't recreate that information. We have links to information we consider reliable and authoritative. You'll want to get if you're in a community served by one of the utilities other than an electric light plant, a local electric light plant, you're eligible for mass save benefits. And so you should be getting a mass save home energy assessment to see if you can improve the weatherization in your home. And in some communities, there are volunteers like me who provide coaching and others not. In Wayland, we have active coaching through energizewayland.org. We have about 5 active coaches now in Wayland, including myself. And I'm not sure what the situation is in Weston. We'll have to get some volunteers trained in the other communities. And then there are paid consulting services available from Abode Energy. They're based in Concord, but a very reputable group, and they provide consulting to homeowners for a fee of $150. So if you can't find a volunteer coach, that might be a good choice, and frankly, money well spent when you look at the cost of the heating system that you might be purchasing. We think well of Abode, but again, we don't have any financial relationship with them. I would recommend, we always recommend getting quotes from multiple heating and cooling installers. Because every home is unique, you'll learn something from each installer about what solution might be appropriate. And you'll see a range of equipment offered, costs, and of course, installer reputations vary. So thanks for listening. I think the plan is that we'll have the testimonials next. So I'll stop my share, and then we'll be available to answer questions.
Thank you very much. Yes, we do have a number of questions coming in, and Nick, you're on next to tell us about your experience.
Yeah, all right. Can everyone hear me all right?
Yep.
All right. I'm going to get up my one slide and go ahead and talk through it. Can you see that all right?
Yes.
Okay. Pleasure to be on here. I wish I had listened to Steve before I made all my decisions, but I'll just go ahead and sort of talk through what I did. So I guess we were a family of four. We during the pandemic, we're living in an apartment, and we quickly moved out to a house. We bought out in Weston. It's a 1962 house. First time homeowner, pretty unknowledgeable homeowner, unfortunately. And I remember going through the home inspection and the inspector saying things like, oh, those AC units are 22 years old. And I thought, well, that's like one of 38 things you've told me, and I don't really know what that means. What it meant was they failed both summers, and I had to have someone come out and take a look at them. And they were super loud and would flicker all of our electricity whenever they came on, and all that kind of stuff. And so ultimately I realized I should replace those. And I went ahead and had a climate focus, decided I should do heat pumps, called up a couple of different installers and got a couple of different quotes to do it. And I ultimately went ahead and replaced them in September of this year. And so I had some old central AC units. Those were connected to Unico high velocity air handlers. So I have high velocity ducts in the house. I was able to connect two Bosch outdoor condensers to that system and make that all work. And I guess, a couple of the other things I didn't really realize when I embarked on this journey. One was that I would need to do weatherization. I'd ultimately need to do weatherization in order to apply for any mass save monies related to the heat pump installations. So that got me going down that track. So I also got the heat pumps installed. Then I did the mass save weatherization, which I think may have been good because I'd have work done in my attic on the air handler. And then ultimately all that's been sprayed now in order to get the home in better shape. While I was doing that, I found out that my gas-based hot water heater was dumping some amount of exhaust out of the hood. So when I saw that, I just and had incentives, I decided to swap that out for a hot water heat pump as well, because we have young kids in the house and we're about to insulate it, and it just seemed like the right way to go. So we've been busy. We've done that. I think by and large, I'm pretty happy with how it's come out. It's quieter. The units run pretty well. They knock down the gas bills, very considerably year over year. I'm trying to get a clear picture of the overall energy stuff. And I do think, as Steve alluded, that I'm probably just a touch higher all in all, but I have functioning systems. And so that probably, that I can rely on and are quiet. So that probably counts for something. And then I guess one other thing I didn't really realize when I went into it was that my, I've got a situation where my kitchen, for instance, didn't have any baseboards in it. So it had no heat from the gas system, but the high velocity vents do go through there. So I'm actually able to warm more of the home now that I've gone and done that. I guess by and large, I was sort of, I guess the other thing I should say is that we maintained the gas boiler as emergency backup. And that is all controlled by one set of smart thermostats. So I guess that's one other thing I've liked going through all this is I had dumb thermostats that I couldn't really figure out the schedules of, and now I've got smart ones I can control from my phone and can toggle between systems and all the like. So that's what's happened in my world. I don't know if there were questions specific to mine.
Yeah, this is Joel. Everybody save your questions for Nick, and let's hand it over to Joffrey. And if you stop sharing your screen, Nick.
Yeah.
Hey, hello. I'm Gottfried. I'm also going to share my screen here real quick. Hope everybody can see that.
Yes.
So similarly, I live in Wayland. I have a home from 1950, I think 51 or 52. I've lived here for now 25 years or so in this home, and had sort of that traditional setup. Actually, originally just an oil boiler here with for heat and hot water. A few years into it, we added an AC unit, actual central air as part of an addition, sort of traditional way that was done in 2003 or so. And then a few years back, I started to sort of think about alternatives here. Actually started to talk to Steve and a few others in the community here, learned about heat pumps, and decided it was time to, number one, throw out an old oil boiler that was, probably 30 years old or so, and the AC system came up to 20 years. So I thought it was time to change that. And replaced it with this type of setup. So actually very similar heat pump setup as we just heard. There are two Bosch units here for heat and cooling. So I got the AC upgraded in a way for free as part of that transition. I could use the existing duct system that we already had in place from the old AC system. There is no disturbance, no change to that at all. I did keep an oil boiler in there. We had to actually replace the old with a new, because we also needed something for hot water. And at that time, we did this actually 2 years ago. I started planning it probably about 3 years ago. So at that time, the hot water heat pump wasn't quite as popular and as easy to find as now it is. So we kept the oil boiler for hot water. We did add also solar hot water just to offset that a little bit, which through the incentives at that time was pretty awesome, actually, how that all came together as well. But now the interesting part is we can use the oil boiler as a backup and have now our smart thermostats set in a way that it switches to oil heat when it's below 20 degrees Fahrenheit, and it's purely on heat pump when it's above 20 degrees Fahrenheit. And Steve, actually, thanks for your recommendation when we talked last. I had originally set to 35 Fahrenheit based on what the installer had told me, but I kind of kept pushing it down. First, I pushed it to 30, and now since I want to say end of October, early November, I set it to 20, and it worked very, very smoothly. So I very rarely now hear the oil go on for heat at all, even when it's pretty cold out there. So that's the general setup. We have it now since pretty much two full years. It's run without a hitch. The going back and forth between oil and electric works very smoothly. You don't notice it. Just one goes on. If at night somewhere the temperature drops down to whatever 15 or 12 degrees or something like that, the oil boiler just kicks in, and that's pretty much it. From a usage perspective, super hard to compare correctly with, I'm sure you all have, so you lived through Corona, all of a sudden you have kids living at home again who weren't at home for a certain period of time, and now they're left again. So I sort of guesstimated approximately, I looked at electric from 2019, sort of while it's still the old system, and larger family in the house, and now the year 2022, which sort of back to normal. And I would say approximately I cut down my oil usage by half. So that was actually better than I thought, because it still does hot water and stuff like that. And my electric usage actually only went up by maybe 20% or so. So at the moment, I'm still scratching my head a little bit how little that's gone up there, and maybe the cooling's more efficient. Maybe we've just used less. That could also be, or we also insulated the house. We did use that program through the electricity provider. I forget how it came about insulating the house, including blown-in insulation in the walls, which made a big difference. So that probably also added to it. And I think that's my story.
Okay, thank you. And again, save your questions for Gottfried. And we're handing it over to, at this point, to Felix. And yeah, could you stop sharing your screen? Thanks.
Can you see my slides?
Yes, we can.
Right. Yeah, so I just want to briefly share our journey from converting our oil heating system with a geothermal system. And so we moved into this house in 2019, and what we had is it's a 1950s Cape, 2,500 square feet. And so the existing heating cooling system was an oil furnace that was installed in 2004, forced air, and it's a single zone. And so one thing that we have a basement, first floor, second floor. What we realized in the second floor, really both the heat and the cooling didn't really work well. I think the system wasn't sized correctly. And then the oil furnace also went on the fritz, so it was kind of time to replace it. And so we decided to go with because we wanted to completely electrify the home and get away from fossil fuels. We went with the ground source heat pump because we didn't have a backup system, and also because we wanted to have 2 zones. And so maybe just so that people can understand, it's a pretty invasive process. So we had 2 boreholes drilled. It took 1.5 days to drill. They're 450-foot deep holes, and then about 20 feet apart. And then the second step then is trenching. So here you can see on the left-hand side, you see the 2 well heads. They're then cut off. And on the right-hand side, you see the trenching. So you have to bring it under the frost line, and then it comes into the house from in the basement wall and into our utility room. And so then at the end of the day, this is how this looks like the whole house for the so we could use some of the existing vents, but we had to change the ducts slightly. So we had to take the ceiling out in the basement to reroute the ducts and kind of close up the ducts for the second floor. And so this air handler and heat pump, which is the number 1 here, is heating the basement and the first floor. And then there's number 2 is like a split ground source heat pump that then gets up to the attic. Number 3 is then the air handler for this, and so that way we could get new vents in the second floor for the second zone. And so now we have an improved setup with now we can have good heating and cooling on the second floor. So that was our story.
Okay, thank you, Felix. Okay, and a lot of questions have come in. I know, Jeff, you've been collecting some of these, but let me just kick it off because we were just talking about ground source heat pumps. And Felix, questions came in about, could you do this along with a septic tank or a well or some other, do you know whether it can be combined with other, like digging a septic
I mean,
tank?
there's 2 ways to do this, right? If you have a lot of space, you can dig it. You can just bury it vertically, horizontally. So you just have to get like 8 feet under the ground, and then you have like horizontal loops. But that obviously is a big thing as well. So it's not a cheap thing to drill these wells and pretty invasive, but it's like in the long run, these wells work for nearly forever. Like I mean, there's no like lifetime on it. So that's something that you have the investment once, and probably we won't get the money fully back. But it's like, for us, it's more important to get away from fossil fuels if we can, which we can. And then on addition to that, we got now solar panels also installed on our, and so 40% of our electricity is over the year covered by the solar. So we reduced that as well.
Okay, Jeff.
Felix, just to follow up on that, we can everyone hear me? Just want to make
Yes.
sure.
Yep.
Thank you all for your presentations. They were excellent. And Steve, thank you for being here tonight. The HeatSmart Alliance does some amazing work. Felix, somebody asked how deep you had to dig for your column wells, and I think you said 450 feet per well. Is that right?
So they go 450 feet, and so we needed 2 wells based on the size of the home.
But my understanding is that just because people sometimes will ask that, like how many wells and how deep do they have to go? It depends, one, on the soil, local soil conditions and geology is my understanding, and also on how many tons of heating and cooling you're looking to offset, right? Or how much energy you need for your project. So two wells, 2 columns that's a reasonable amount for a residential site, I think.
It's just one wasn't quite enough. Like, so it's like,
yeah, one rule of thumb, it doesn't, because of variations in soil conditions, but is about 150 feet of well per ton of capacity.
On a cooler.
Yeah, and you want to make sure you have adequate, it could be adequate capacity when the heating season starts in October, but by the end of the heating season, the ground is cooled off because you've extracted heat from it, and so you need to make sure it's got enough capacity to deliver heat to the home on a cold day in March or April.
Right, the efficiency of those systems diminishes slightly as the winter progresses, correct?
Yes.
Right,
Yeah, but that's a slight decrease.
So Steve, a question maybe for all too. I did not hear any talk about the maintenance costs, the ongoing maintenance costs when compared to, let's say, gas or oil or boilers or whatever. Any sense about how a heat pump compares?
My sense is it's lower because you don't have particularly with oil, those oil boilers or furnaces need to be serviced every year, and they have to replace the burner tips and so forth. It really needs to be serviced. I find folks are less diligent about maintaining gas furnaces, but they should be maintained as well. And with heat pumps, a checkup once a year by the installer, cleaning out the coils. Usually there's not much for them to do. The main thing is to make sure that the the coils on the outdoor and indoor units are unobstructed. And homeowners should, there are small filters, depending on, they all have filters of various types, and just like fossil systems, the homeowners should be sort of staying on top of replacing or cleaning those filters on a regular basis. But
I want to say I had sort of my old air conditioning unit. I had sort of the annual maintenance contract with the air conditioning company, come change the air filters and just check on the system. I'd say it's virtually exactly the same price, just continued with a different company, but same service. They just serve as the heat pump instead of the air conditioner. Same thing, nothing extra.
We got a quote from our installer offering us $250 a year for annual maintenance visit. We haven't signed up yet, but that's a benchmark.
I'd say that's a good deal.
All right. We have a couple more questions about just heat pumps in general. I thought, let me just tick through a few of these here. Laura asked, can you add a heat pump to a high velocity AC system? I think that's what Nick did, no?
Yeah.
So the
Indeed.
answer is yes, you can.
And I spoke to a couple of references who had done that before I did it as well. So I think it's a little less typical and not probably the most efficient Steve would know better than I, but the most efficient possible setup. But obviously got those ducts as I did. It's practical and it works all right.
Yeah, that's right. The high velocity systems were sort of, before these mini splits came along, they were the solution for adding air conditioning for homes with hydronic heating that didn't have ductwork. I think they're rarely added now, and there was really only one vendor of those systems, Unico, who you mentioned. And it turns out that Bosch heat pumps in particular are the most likely to be compatible with those Unico systems. The one caution is that they may not qualify for the mass save rebates because the Unico Bosch combination isn't on the qualifying list that mass save maintains. So I don't know, Nick, were you able to get a mass save rebate for your system?
Oh, I think I'm actually not sure if that's fully processed. I did mass save for the weatherization and hot water heat pump and the like, but perhaps I couldn't do that one.
Yeah.
There was a question about hot water heat pumps, in fact, about comparing them to a traditional hot water. Can you take the same number of showers simultaneously? Does it supply enough water? Do they work?
Absolutely. So it's usually advisable to get a little big. If you have a small tank now, 30 or 40 gallons, you might want to go to a somewhat larger tank for the heat pump water heater. But they're called hybrid water heaters because they do have electric resistance elements to catch up when the hot water in the tank is used. So ideally you have enough capacity. If you have a 60-gallon tank, that'll handle quite a bit of use before you have to, you try not to draw on that backup, the electric resistance as a backup, because it is less efficient than the heat pump, but it is there. So people who have these heat pump water heaters have pretty much the same experience as using a conventional water heater.
Yeah.
Steve, could you we have a basic sort of broad question, but I think it might be helpful for people to hear your approach. This is from Carol, who says, I have, let's see, a 100-year-old house with no ductwork. I have a boiler and steam radiators, no AC. What would you recommend? Starting with insulation, I'm guessing, no?
Yeah, definitely starting with insulation, and you'll want to get a mass save audit, but you may want to consider, there are cases where insulation can be done, but the mass save program doesn't do it. So you might want to talk to some insulation companies that will do work outside of the mass save program. It will cost you more, of course, but it may be worthwhile for an older home like that. In terms of heat pump options, you're most likely going to be considering a ductless type of system with one of the types of units that I mentioned, wall units. If you don't like the aesthetics of wall units, you might consider the floor mounted units that look similar to radiators, the old fashioned sort of radiators. They're in a nice box, fairly unobtrusive. Joel has a couple of those in his home. And then there are also those small ceiling cassettes, which would be in the ceiling. I wouldn't recommend those on the first floor. You'd try to get the heat source lower, so the floor mounted units would be desirable. On a second floor, you might consider those cassettes. But and usually the refrigerant tubing to those units can be put in inside the house, or if there is some conduit for the refrigerant tubing outside the house, installers can do a pretty good job of making that not visible, hiding it behind shrubs and so forth. But that would be something you'd want to talk with the installer about, where they would run that tubing.
So this brings up another question that was posed, and that is with the ductless mini splits and the add-on systems. Thermostat challenges. How do you control the temperature if you install several mini splits? Does each one come with its own wall-mounted thermostat? What would be in addition to your backup heating and AC thermostats, or how does that work? Do you have like Felix? Do you have multiple handheld thermostats in your house for each zone, or how does that work?
No, for the whole house system, we have like the upstairs zone. Yeah, so we have a smart thermostat upstairs and one for the zone downstairs. But I think for the mini splits, it's a little bit more, can be a little bit more complicated, I guess.
Well, we have a mini split, and I think Nick and Joffrey can add to this, is 3 units, 3 different rooms. Each one is controlled entirely independently, except you can't have one on air conditioning and one on heating. You either do, heating or air conditioning, but they're all completely separate. You can turn off one and turn on the others. I should say too, we have 2 different, one in a dining room, one in a living room, with a big 4-foot wide opening between the 2 rooms. I've been very impressed with how you could just run it in one room and heat the other room. I mean, they really generate a bit of heat. Even though we went with separate units and 2 separate rooms, it's conceivable we could have even had one covering the whole, combined space of probably 900 square feet. Any of others
Yeah,
had any?
so the default is the mini splits are put in with a handheld controller. I find the handheld controllers are not very user friendly. It's sort of there's 20
To
buttons
put it mildly,
on it, and they have a small screen with tiny icons that are, if you need glasses, you have to have your glasses on. So I usually recommend, when people are getting quotes for mini split systems, that they ask the installer to quote, either as part of the quote or an add-on option, adding wall mounted thermostats to the system, for 2 reasons. One is then you can also control it sometimes from a phone, but also having a thermostat where the temperature sensor is away from the unit itself usually results in better temperature control. So and then that single wall mounted, they can be configured quite flexibly, so a single wall thermostat can control multiple indoor units. There's also from Mitsubishi, and I believe from the other major manufacturers, control systems, again, an add-on for Mitsubishi. It's called their Kumo system. That's an add-on to each wall unit and a separate control box, and it allows you to control the whole system from a phone. And again, you can group the units by zone. I have that system in my house. So there are a lot of control options. They can also be interfaced with third-party thermostats. So this is something when you get quotes, a lot of the installers will just quote a thermostat. You want to pay attention to what they're quoting you. Is it a bottom-end thermostat? You actually have to go and look at the specifications and make a judgment. Is that a good thermostat, or you might want to upgrade it? Usually the thermostats are a relatively small part of the overall system cost, so it's worth paying attention to that.
Just a general question too. You started by talking about mass save. People wondering about what happens if you didn't call Mass Save to begin with? What downstream might be the result? And also the importance of the insulation work. Someone had asked, what if you just spent the money just doing insulation and skip the whole heat pump? Could that be a better deal?
So if you want to get the Mass Save rebates for heat pumps, you have to have had a assessment done by them, the free home energy audit, within the last, I believe it's the last 2 years. It might be the last 3 years. So if you install the heat pump and then go to Mass Save and you didn't have that audit, they will say, sorry, you don't qualify for the audit. If the audit recommends additional air sealing or insulation, you also must have that work done in order to be able to be eligible for the Mass Save rebates. So the audit is harmless. At worst case, they'll come take an hour or so in your home. They'll do the audit, and and they'll discover that there's nothing further to. If they've already treated the home in previous years, chances are that they won't recommend anything additional, and then you'll be qualified for the rebates. As to the question, even if you take a typical, let's say, home in this area, an existing home, adding insulation will make it more, my experience is it will make it more comfortable because you'll have less, the rate at which the home loses heat and has air infiltration will be reduced, but it's hard to measure how much actual savings there are in the heating cost. And so, best case you might get, if with the standard Mass Save treatment, you might get, let's say, a 20% reduction in your heating demand. You're still going to be using a lot of fossil fuel to provide heating, that you've reduced your heating footprint by 20. And with a heat pump, you're still emitting, you have carbon emissions with the conventional heating system. So it's still beneficial. And to get beyond that 15 or 20% savings, then you have to do some things that are very costly and can be quite extreme, such as removing the interior walls and foaming them, or removing the siding and putting in an extra layer of foam outside the home. So those kinds of changes, which are called a deep energy retrofit, can be quite costly.
Steve, we've gotten a couple questions regarding air to water heat pumps. Alan B writes, our house is heated by a gas-fired boiler with circulating hot water, a hydronic system. Can the boiler be replaced with a heat pump and still retain the superior heat quality of radiators versus forced hot air through splits? If so, does a hybrid heat pump hot water heater boiler make any additional sense?
So the answer is yes, there are air to water systems on the market. There are only about 4 or 5 installers in Massachusetts who install those systems. A lot of them use imported equipment from Scandinavia. And I had one coaching client in Wayland who did a lot of research on them, and then we did some research in the HeatSmart Alliance. We have a pretty good piece on our website about some of the considerations with air to water systems. But you're probably, the experience of this Wayland client who researched it quite thoroughly was that the costs came in about 30 to 40% higher than a ductless mini split system. So you're in for some additional cost, and you don't get air conditioning from that in order to get, because you're concerned about if you ran cold water through those pipes, you would get condensation that could cause water damage. So to get air conditioning, you're still going to have to add some wall units or something like that. And so that's where the part of the additional cost is. So for most, unless you have, in this climate where we need both heating and air conditioning, it's going to probably end up being a more costly solution than a ductless system.
Very helpful response. Ken Wilson, let's see, writes, I have a two-family house that we own, both units. Each apartment has its separately metered heating and cooling system. Are the mass save incentives and the federal rebates under the Inflation Reduction Act available to us for both units if we install heat pumps in both units? I guess it's a two-family apartment building.
Yeah, I'm not, I should know that, but I would take a close look at the Mass Save website and possibly contact them. There would be some, if the tenants were income eligible, there might be some additional benefits there. I don't know what the case would be if it's two separate units. It would seem reasonable that they would separately qualify for the rebates, but I'm not certain.
Another question about water heaters, and there's the, as you said, there's a traditional sort of 40-gallon tank heated by electric resistance or by gas, but there's also tankless water heaters, which we just installed one recently with the gas water heater. How would a tankless water heater compare to a heat pump water heater? Any sense of that?
Well, the tankless water heaters are usually, if it's powered by oil or propane, that's probably a bad idea. Certainly if it's powered by oil. If it's a propane or gas tankless water heater, I have not looked at that comparison, but given the relative costs of gas and electricity, I would imagine the operating cost would be similar. But of course, higher carbon emissions from the tankless heater.
Someone asked, what's the efficiency rating between a central heat pump system and the mini ductless splits or mini splits?
So they have the better central air source heat pumps are quite competitive with the ductless mini splits. One of the things that's surprising about these ductless mini splits is that the smaller units are actually more efficient than the smaller single zone units are actually more efficient than the multi-zone units. So a 1-ton single zone unit or even 9,000 BTU per hour single zone unit, actually, if you look at the specifications for them, can have almost double that rating in heat output. And so you can actually, and it's unfortunate that very, very few installers propose these single zone units anymore because it's less cost to put in a multi-zone unit with multiple indoor units as opposed to these one-to-ones. But they're actually the most efficient air source heat pumps. And then second, I would say, would be the central air source heat pumps. The multi-zone heat pumps have very good specifications at higher outdoor temperatures, but they decrease with lower outdoor temperatures, and in the field, they appear to deliver somewhat less efficiency than the central air source heat pumps, in my experience.
Okay. And Jeff, I think you had a final, getting to the end of our time slot here, a final wrap-up question.
Well, just could someone ask, I thought this is a good question. Can the panelists talk about what they use for backup heating in power outages?
Sure. Number one, as I described, we have both. So we still have the old oil boiler, and when it gets really cold, that kicks in. At the same time, when you actually do have a power outage, even before this whole thing years ago, you have a power outage, the oil boiler also needs electricity to work. So generally, you're out of power either way, unless you have then a generator that's actually wired to turn on your heat, which I think most people don't have. So in the extreme situation of no electricity, I think we're all back to the fireplace and things like that. But as I said, the back and forth works well. And maybe one other word to the comfort of the water-based heat versus the forced air heat. I was actually quite concerned about that initially because I don't like sort of warm air blown at me. I do have to say it's hardly noticeable that whole thing of the old thing of like air conditioner comes on and cold air is blown at you and it goes off again is no longer. It's super smooth. You don't hear it, you don't feel it. Just the air just is warm. So I would say there's almost no difference between the two. Maybe they are slightly drier. That might be the only thing.
Very little to add to what Gottfried shared. I have a similar system and similar experience throughout. I have a heartbreak story about trying to get my solar installer to put in batteries, and none of them have much confidence they can do it well, and so on and so forth. So I do have a generator that kind of breaks my heart, but probably I'm not going to be able to fix that problem quite yet with a degree of confidence I yet feel comfortable in, though I tried. Anyway.
That just reminded me, just one more question, but I've two neighbors have said, oh, they were sort of interested, but they were concerned about the outdoor unit being too noisy for their neighbors. They didn't want to bother their neighbors with the outdoor units. Have you had any feedback from neighbors or your own family about the noise?
No, it's not very noisy, and it's in my case probably a third of the noise of the previous AC condensers. So I'm definitely going in the right direction.
I've asked my neighbors. They obviously go on more often because it's heating and cooling. Cooling is just in the summer for a couple of months, and now it's sort of year round. It does get, I think the colder it gets, maybe it's just my impression, it does get louder because it maybe just runs longer. It just feels like it gets a little louder. I've asked repeatedly, nobody seems to be bothered by it, and so no issues.
Yeah, and Felix, your neighbors don't even know what you're doing.
No.
Yeah, completely silent. Yeah, so most of these, the heat pumps that work well in cold weather are variable speed. That's sometimes called inverter driven because they're the inverter converts the grid's AC power to DC power so that they can run variable speed. So during most of the heating season, they're actually not running anywhere near their full capacity. They're running at partial capacity, which means lower speed, and the lower speed, the less noise. So these newer heat pumps of all types are much quieter than older air conditioners. Older air conditioners ran at a single speed. They were either on or off, or at most maybe 2 or 3 speeds. And when they were at their top speed, they made a lot of noise. The manufacturers also made a lot of strides in noise engineering. They've reduced the noise output from these machines so that they tend to be very quiet. And it would be only in extreme like cold, like 10 degrees, 5 degrees, which we don't have very often, that they might be noticeably more noisy.
Okay, good. Yeah, I've not noticed any unusual noises from my new system either. Well, thank you very much, Steve, Nick, Joffrey, and Felix. Thank you very much for taking your time out and helping to educate us. And I hope everyone learned something and are a little closer to making an informed decision about how you want to involve your own heating system. And as Steve said, best not to wait until you have a heating or cooling system fail. Start thinking about this a little early. And to help you think about it, I'd recommend, again, going to HeatSmartAlliance.org. It's in the chat. It's already been put in there. And there's a lot of resources, a lot of pointers to more information to continue that process. I know it's a new technology and requires a little bit of getting up to a comfort level. And also repeat, this session will be on MetroWestClimateSolutions.org. Where we will also post some references and some pointers as well. And you can also sign up for our newsletter on MetroWestClimateSolutions.org. If you're interested in becoming a coach, learning more about all this and helping out HeatSmart Alliance, as Steve talked about the coaching system they have, please contact Steve. So thank you all very much for attending, and we'll wave goodbye. Thanks.
Night, everyone.